Hello. So we are back, yeah. But this is kind of, it's my revenge video. Okay. Let's go back in time, 1 year ago, yeah. Remember this video? Huh? Do you remember this video? I will leave the link on the description anyway. Was a job, and actually I'm very proud of this video because it was like pure using pure like knowledge just to find to figure it out what is there. And I remember I start probably from the power button going back to the processing units to the power supplies, and finally we found the problem. But this was quite a good one. Yeah, let me see, let me find the job. Let me find the job. Look there. Yeah, so that's the job. You see that big speaker from there? Yeah, that's the job. That was a Sony speaker. Okay, that was a Sony speaker. And we open everything and we start checking from the power board, from the power button actually, yeah. And we go further and further, and we found out actually the 3.3 volts power rail is missing. And after that we found out the 3.3 actually is coming from the 5 volts power supply. And that was the 3.3. Yeah, okay. And after that the lead goes on the 5 volts power supply. Yeah, that's the one. So this one with the switching and this fast diode, yeah, that was the problem. So now I remember. And after that, what we found, I will stop here. I'll stop here. I'll stop here because today we have the same job. This is a blue one. Okay, same job, same speaker. Okay, I did open the screws. So let me take out the board. What are the odds to have same fault? By the way, that job, which I got a lot of hate. If you look on the video, I had like 56 dislikes because I modified the power supply and I used a linear power supply 7805, yeah, instead of the switching one. I took a lot of hate from that one, but that job never come back, like under warranty or after that. It's 1 year and the job didn't come back. Okay, so those screws are out. Yeah, you remember that part? Okay. We have to take the board and the board and everything. All this metal thing. Let me take it out, yeah? You can't see. Yeah, that's the one. Okay. And I'm just curious. Do we have the same fault? Huh? It's what? It's one thing what I learned. Yeah. Long time ago I learned this. If you rise up the complexity of a circuit, the chance to that circuit to fail is rising up on the same way. Yeah. So I know. Just that 7805. Actually, I felt very confident to use it there on that situation. Just because it's a linear one, with linear ones, you have no issues. The only problem is the heat because they are linear. Compared with the switching power supply, which is true, are more efficient. The switching power supply are more efficient, but the chance to fail and chance to have like weird faults is a lot more higher. but I paid the price. You know, I got a lot of hate on that video. It's kind of hate comments. You can't see them on the channel. They go straight to the spam, and I can see them. But trust me, it's you know, not everyone understand, and they think actually, you know what, the manufacturer is like God, and we are like some kind of slaves, and we have to follow the manufacturer. Obviously, if we found here the same fault, does mean the money is not like a random fault, it's a manufacturer design fault. Yeah. So I haven't checked anything, and I will not start again. That was a long video, it was like 2 hour video. I will not start again checking from the beginning. I will go straight on that power supply, and I will check if we have 5 volts. Okay, we have. What do we have here? We have 2 more screws. Give me 1 second. On the sides, yeah. Here and here. That's out. And 1 more. This speaker looks very used. Yeah, this is a Bluetooth speaker, Sony one. Looks very, very used. So what do we have now? We have few ribbon cables, like the speaker ribbon cables, and I think are some lights on the front. Okay, I have 1 more. Good, and 1 more here. And what do we? Okay, we have 1 more ribbon cable, and that's all. And no, 1 more. Now it's off. Yeah, that's the one. Yeah. So let's see now what's going on here. The first, the power input on this speaker is broken. You see this one? So this is moving, but looks fine. The wires are there. It's nothing dodgy. It looks fine. I'll plug this. Don't worry, we'll fix that on the end. We'll fix that on the end. It's not working. I checked already. It's not working. We tested and it's not working. It's not coming on. That's the problem. Okay, so you are ready? Yeah? Okay, let's test it. It's on. Let's take the multimeter and we will check straight away the 5 volts. Yeah? Diode mode. Okay, let's change on volts. Ground. And the output of this coil here. And we have 0. Let's see if we have the input. Yeah? The input of that chip. Let me see. The input of that chip. Let's see. Check on the multimeter. 34 volts. You can see, check there on the multimeter on this pin of this chip, yeah? On the pin of this chip, 34 volts, yeah? So let's check now, let's see. Here, I should use the microscope for a better view. Yeah, so same circuit here. Yes, that's the one. It is on focus. So let's check input on this pin. Check on the multimeter, 34 volts. You can see on the multimeter 34 volts. So what do we have? We have the coil, and after the coil we have this Zener diode and the capacitor, and here is supposed to have 5 volts. Here, sorry. Yeah, we don't have 5 volts. But on the input of this chip we do have 34 volts. You can see. So you see, it's kind of path. We have the same fault. So it's not like something like a random fault. No, this is clear. It's a manufacturer mislead. It's you know. What I will do. What I did there. So what I did there. I was checking that one, okay. And I was checking the diode, and the diode I have 0.5 ohms. Yeah, you can see there, checking the diode, and I have like 0.6 ohms. Let's check here. Let's check this diode. One problem. I don't have a 7805 right now, yeah? So we have to fix it, but we don't have that linear. So let me switch on diode, yeah? Diode. And same thing, 0.003, yeah? Let me unplug it. Let me unplug it. Yeah? 0.0 is short. You can see that it's completely short. It's short. Yeah? So that Zener diode, not necessary to be the Zener one, can be something on that circuit. But what we'll do next, let me see what I did next here. I did remove the diode. I checked the diode was good. Okay, so I'll not remove the diode. I use petrol and I come with the power supply probably to see what is getting hot. Very smart move, very smart move. But I should do it before checking the diode. So we are still in the learning process. Power supply. I don't remember what was getting hot there. But if I remember, was that Zener diode, yeah? Yeah? It's there, down, there. Yeah. So let's go a little bit further. What we found? Yeah, we found the diode. So actually the diode was getting hot. Yeah, this switching diode, fast diode. Okay. So let's check here on the same way. Let's take some petrol. We have petrol. That's good. It's unplugged. It is unplugged. Yeah. Let's come with the power supply. 5 volts, around 3 amps. Now let's see. Yes, it's taking 3 amps. What is getting hot? What is getting hot? We don't know. Let's go 5 amps. 5 amps. Yeah, 5 amps. 5 amps. That diode looks weird. check there. No, no, no. Look. Check there. Check there. Yeah, check there. I will put now. Now. So what do you think? What do you think about the diode? What do you think about the diode? The same fault, same diode. And if I remember, yeah, last time it gave me a lot of headache to find the same diode. But let's see online. Uh, SS34B. Yeah, that's the one. Yeah. Give me 1 second. Sorry? Yeah? Yes? Okay. Okay, give me 1 second. It's a customer there. Okay, good. Let's see. Three, 4B. This is a very fast diode. I didn't switch. Sorry. Schottky diode, yeah? Schottky. Schottky, sorry. Yeah. I remember people correcting me. Schottky diode. 40 volts, 3 amps. The problem is, yeah, this is a fast diode. So we have to find the same one. And I don't know where we can find the same one. That's the problem. I don't think I can find another one like that. So I'll remove the diode. Because this is gone, obviously. Sorry? Yeah, the back cover. Okay? So I'll remove the diode and I check again the 5 volts for short. Yeah?
Basically, cost 36.
Okay. So let's remove the diode. Sorry, I have like 200 degrees here, Celsius. We need 500. So the diode is removed. Let's check now for short on that center diode on the output of the 5 volts. There. Okay. And it's not short anymore. You can see on the multimeter, it's not short anymore because our diode is dead. So all what we need now, yeah, we can check the diode. We can check the diode. That's the diode. This one, the black one. Yeah, that's the one. And if we check the diode, it's short 0, 0. You can see on the multimeter. So the diode is dead. The problem is where can I find another diode like that? Last time I go on a very wrong way. You remember we took the diode from another power supply and we burned even that one. So we took the diode from where? We took the diode from here, you remember? From here. So I don't want to go on that way like last time. Yeah. So let's get it right this time. Yeah. Let's get it right. What do we have here available? Available we have a PlayStation power supply. Do you think we can find any Schottky diode here? Hmm? What do you think? What kind of diode is that one? M360B. What's that? M360B. 360B diode. It's a 3 amp Schottky diode. I can't believe 60 volts. Yeah, 60 volts. 3 amps. We are saved. Oh, you can't see. Sorry. Yeah, that's the one. 360B. I think that's the one. Yeah. 360. Yeah, must be that one. Images. Diode. 600 volts. No, I don't think. No. Okay, you know what? Let's see where the diode is used. So this diode is used. Let me check. This diode is used. Capacitor. A pin from the transformer. And it's going to, yeah, that's fine. That should be fine. 1 second. Where did I switch? 1 second. The next one. Wait, we have one more. B36B. What's that? B36B. Okay. Okay. I don't think this is a. It's ultra fast diode rectifier. But this is not Schottky, yeah? Bidirectional high voltage diode. Yeah, no. This one. B360B Schottky diode. That's the one. So we have to use that one, yeah? So let's remove that one. Man, we can use a big one, a big diode. Come on, we have big diodes here. Yeah, let me check. Yeah,
Can you put power in this battery?
yeah, yes. We have big diodes there, yeah? What diodes do we have there? We have big diodes. We probably are high voltage diodes, and we don't need high voltage. Hmm. Let's try, yeah, let's try. Let's move the diode. Give me 1 second. Okay, just give me 1 second. I have to charge a battery. That's a good battery. It's taking 2.5 amps, 4.8 volts. It's a Huawei battery. That's how you charge quickly the battery, yeah? So it's taking 2.5 amps right now and it's fine. Has no problem. Yeah, the battery. Ash, the battery should be fine. Let's move the diode. Okay, let's move it. So it should be there, yeah? Yeah, the diode is perfect. Let's test it. Let's test it. Let's see if it's working. Let me cool down the diode. So good to be right. Okay, let's plug it. Let's see, it's smoking or it's blowing. It's fine for the moment. Let's check the voltage. Multimeter, volts. And we have 2.3 volts on the channel. 2.3 volts. You know what? I don't even know what is the. I remember. So now I remember. We have same problem. We try few diode, and we got same issue. Actually, we got like something like that, like 2 volts instead of 5. So I don't even know what is the problem. Actually, the diode is not switching fast enough. Let's see, 5 volts. 5 volts. It's taking like 300 milliamps. It's not short, so it's no reason to be only like 2 volts. Okay, let's try to find another diode. We have a TV board here. Let's use a big one. What's this? What is this? You know what? I'll use a big one. If it's a Schottky diode, and it must be. Oh, this is a 5 amps one, which is even better. Let's see. 1N54 1N5408. What's this? One N 5408. Standard recovery diode. Is Schottky or not? Images. I don't think it is. I don't think. Okay. What about this one? Yeah, let me check this one. No, that's not Schottky diode. Oh boy. What about a new board, Samsung TV? What about this? Should be here, yeah? This is a new board, new technology. So what do we have here? 1N540, yeah, same diode. Okay, do we have some diodes here? Let's see what diodes we have. SK24. What's that? No, 1 second. PG 34 A6. No, I can't find anything like that. Okay, let's try the other one. The other number, which is SK24. SK24. Okay, I found it. Yeah, I found it. Schottky diode! Finally! So what diode is this? 40 volts 2 amps. That's enough. Should be fine. Should be fine. It's unplugged, it is. Okay, let's dip this diode on flux a bit. Okay, let's solder this diode back. So I don't think it's a diode problem. I think now will be the same. I think the chip is the fault. So I think we'll end up replacing that power supply with a different one. Because if it's not working now, I will not replace diodes. I will replace the power supply. We have some switchy power supplies here, you remember? Let's see. Ah, you remember? This is too small. Don't worry, I have a bigger one. A bigger one. I should have somewhere. Oh, look here. 5 amps. So it's not a problem. Yeah. Okay, let's test it. Plugged in. Multimeter. Diode. 5 volts. I can't believe. Check that on the multimeter. I told you that diode is not fast enough. 5 volts. Yeah. 5.060. So if you don't have the original diode, you can replace the diode with a different one. Or you can replace the old power supply with a different one. It's not hot, not cold. Not great, not terrible. Let's test it, yeah? But what I will do, what we can do with this one, this is cracked. How we fix something like that? How we can fix something like that? The plastic is missing. You know how. You know it. So it's interesting, you see. I was thinking the diode is not fast enough. If the diode is not fast enough, it can't keep it up with the chip which is switching. Yeah. And the diode will be left in the back, and yeah, you will end up with low output voltage. But it's just a deja vu. Because already we work on this one. We figure it out. We start from nothing. We start from zero. I remember even after I finish the job and I upload the video, the people were trying to helping me to understand the things, and I remember they told me this pin PSO PS on. Yeah, that's the pin which will start the power supply. I still remember. I still remember. So same fault on two completely different devices, same brand, same model. Yeah. Give me 1 second. Looks okay. Just wait to. I'll put this back. Yeah. Yeah. Okay. 1 second. Okay. Sorry for that. Uh, let's put this back. Oh. So should be like that. Yeah. and we can test it. What did you said? You said actually I fit a 2 amps diode instead of 3 amps and the thing will die? No. No way. You have 300 milliamps. Remember we checked with the power supply, yeah? So again, it's same with the car tanks. When it's empty, actually it is there is more. And they always put more. Okay, so it's nothing to worry about. Just obviously, if I need a 1 amp power supply, I will stick there a 3 amps power supply just to be sure it has a lot of, leverage. You know what I mean? The power from there was like 300 milliamps. Having in mind, it's a 5 volts power supply. Probably if the man will stick like 2 3 USB, yeah, like phones to charge, yeah, maybe. Well, I don't think so. And one more ribbon cable, and that's all, yeah? That's all what we have here. Okay, the ribbon cable is connected. And the cover, I'll put all back together. Obviously, I will put all the screws, but just one now to check quickly if it's working. Because it's like nearly 5 o'clock, and that's the point when the people come to collect the stuff and it's very busy. Really? No, don't say that. Yes, 5 volts. So what I forget? Yeah, it's not 5 volts. Okay, input. It's no input. This means it's no voltage. I don't know. It's no input. It's when the power supply is not on. I don't have 34 volts. That's what I'm checking. You remember the input of that chip? 34 is not. And the monitor just goes off and my multimeter get. You think something can be shorted, like one of these connectors which I just plugged them in? You think that? Can be. Can be. That's the power. Okay. It's fine. We have no voltage for some reason. So our big power supply is not working. You think that is shorted? I don't believe that. I don't think it's good, has no problems. But we'll check. Diode is not shorted. It's not shorted. The diode is fine. We have no power from the big power supply. What can be here? We have this connector. I did plug this wrong. Do you think? No, but we'll take the connectors out, yeah? And we'll check again. Let's see. It's nothing. Something is shorted here. Okay, you know what's broken? This wire, which is from power. Okay. So you see here are two wires, which probably customer made them like that. The first wire is broken. This one. That's the problem. I can't believe. I was thinking, you know what? It's something wrong there. Well, actually, it was this wire. Just a coincidence, you know. The wire get broken exactly when I finish this. This is soldered, so we have to solder one. I got scared, you know. I say, you know what, it's different. So I plug the connectors and I have no voltage. So must be something else on the top, yeah? On top of that diode. Here you can see, no? We just solder that wire. Great. Now we can test. You know what, I should use some hot glue even here. Just to make everything safer. Maybe the customer will open again these things and he will touch with the fingers. That will not be good. That's fine. Let's put it back. Now let's test it. So you have to replug the connectors.
All of these are reset. I think some of them are ready to set. But that's why I want to check.
Everything is plugged. I think we are ready.
But these ones, like, no, I'm saying the one that's this one I tested it halfway. It's like I know some that are looking good and the software good. They're ready to be put in this. I just need to preach, right? So
Yeah, we are ready. Let's plug it. Plugged.
I'm gonna just put some on the side that I think they are good.
Power.
I'm gonna just put them in there for now because it's not me crazy.
We have lights, yeah. We do have. Look,
The lady that you want me to get
all these lights. Let me check with my phone.
telling you the iPhone 4 and the over information.
Bluetooth. Nothing. The Bluetooth is not working. So this doesn't seem to be working. The logic board. That's bad. Why is not working? Do we have the 3.3, the 5 volts, everything? 5 volts. 5 volts is fine. 3.3. We don't. Okay, I think we missed something. And I think I have more faults here. 3.3. No, we have 3.3, yeah? So we do have 3.3 here. We do have 5 volts on the connector, on that connector. Oh, that's bad. What can be wrong here? So this is oh, look here, look here, look at this cable. It's all broken. We are dead. Uh, and I didn't broke it. Maybe the customer play with it. We are dead. How do we fix something like that?
Sometimes I think about you, like, how much one day for every job, like only like sometimes when I see you talking to a customer, I want to tell you something so bad, and I tell you to when you talk to a customer, like something that's oh, like I don't even want to do it to them.
How we fix something like that? No, really, really, really. How we fix something like that? That's so, that's crazy. And I thought, you know what? We finish. Huh, it's 5 o'clock. In half an hour, I will leave. Hmm? Okay. Don't worry, we are good. Now I need a scissor. Give me 1 second. Yeah, let's do it. Let's do it. Let's do it. Yeah, this is one piece, which is fine. So you can just cut this finger down. Yes, we cut it down. Now the hard part is to get the plastic out from each pin. How can I do it? Because I don't have to broken the pins. It's same like on the Apple ribbon cable from the touchpad to the board. You remember we made one? Nah, this is not working. Ah, we have to use the cutter. No, we can't use the hot air because this plastic cable with metal in will shrink. You know what shrink? So that will happen if we try with air, with hot air. So we can't use hot air. But you have to carry on. You remember we spoke about that. Bad things happen, you just have to carry on. But I haven't broken this one, not me. Wasn't me. Trust me, not this time. Not this time.
I like that part. I like the thing around. Like, you know, light goes around. Bro, like there's like a little light that.
You know what it needs? Better.
Hello? Can you hear me? I like that shit. That shit is nice.
Probably you can't see because of the reflections. Okay, let's check now. Let's clean the thingy. Yeah. Let's clean it and let's check.
How you doing, sir?
Yeah, this is too sensible. I have few pins shorter than normal. Okay, just cut my finger. But not too bad. That will happen when you are in a rush to finish something. So I'll use this cable on this side, yeah? I'll use on this side, here, not on that side. Let's check. Power cable. And we do have the power light here, the power have the power button. Yeah, it's flickering. You can see it, and it's on. And on the Bluetooth, let's see my Bluetooth pairing. Yeah, that's the one. Connected. Music, songs. It's working.
When there's no hope hiding, no chance concealing what deep down I felt for you. And I regret for losing the one who loved me, for who I can't go back to.
Okay. Yeah, keep in mind. Yeah, keep in mind. You just have to. You just have to carry on. Okay. So we fixed the speaker. Everything is fixed. Yeah, I did cut my finger, but probably that's the part of the job. Anyway, thank you for watching. Like and subscribe if you like the video. And see you on the next one, yeah? Bye.